So, welcome. Thanks for having me. So, my name is David Delabassee. I work at Oracle, and today I'm going to discuss Java EE and, more importantly, Jakarta EE. If you know me, you know that I've been working on Java EE for many years, and recently I have changed jobs. So, since last week, in fact, I'm working on FN, Project FN, which is an open source fast platform. So it's a serverless platform that is using under the hood containers. So if you are interested in fast and serverless, I'd encourage you to check what FN is. It's a really cool project. So you might have heard that I have a funny accent. I also have a name that sounds very French, but I'm not French. I'm in fact from Belgium. So before we start, I just want to share a few quick facts about Belgium, because Belgium is a very small country. But at least we have something which is quite important in Belgium. I mean, the Belgian cuisine, and more importantly, the Belgian food is something that we are quite proud. So I just want to share a few facts about Belgian food. So first, we have the Belgian beers. Yes, we put beer into the food category. So over 1,600 different types of beer for a very small country. That's quite a thing. And in fact, Belgian beers have been put on the UNESCO Cultural Heritage List. So that's something that we're quite proud. And then there's the Belgian chocolate. I mean, if you attend Nicolas' session, he is claiming that Swiss chocolate is the best. He's not quite right. I mean, Swiss chocolate is very good, but the best chocolate is from Belgium. We produce more than 20 kilograms per inhabitant per year, so that's quite a lot. And then there's this, the French fries. And, well, it's not French fries, it's really the fries, and they are coming from Belgium. And there is I mean, if you check the Wikipedia page of fries, there is a whole section that basically go over this battle between Belgium and France. And I mean, if you read that, we have all the facts that prove that fries are coming from Belgium. And then there's the Brussels sprout. Anybody enjoy Brussels sprout? Whoa, that's quite a lot. I'm sorry for you. And well, I have my own theory, and I'm pretty sure that the Brussels sprout are not from Brussels nor from Belgium, but they are coming from France. So, anyway, let's move on. So it's a very exciting time for Java EE, because I mean, there's two important things that have recently happened. So I was here last year, where I was going over what our plans were for the platform. But since then, Java EE 8 has been finalized. So last summer, we have finalized all the specification. We have released Glassfish 5, which is the open source reference implementation. And there are different vendors that are working on making sure to add support for Java EE 8 in their own application server. We, on Oracle side, are working to ship this year WebLogic with Java EE 8 support. So Java EE 8 is a done deal. But at the same time, we also announced that basically we would like to change how things are moving forward. So we want to change how the platform is evolving from now on. Because over the years, Oracle, as the Java EE specification lead, got many complaints about how things were moving. For example, one of the complaints that we had for many years is that the platform was evolving too slowly. Another complaint is that if we want to add something in the platform, so let's say that there is now a new useful API that we want to add in the platform, well, we have at best to wait for the next release of the platform, which might be 3 or 4 years away from us. Another issue is the fact that until now, given that Oracle was the spec lead of the platform specification, basically it was more or less one single vendor play. Oracle had a strong say about what would make it into the platform and what should be left out. So we basically want to change that. We want to reboot the way we develop the platform. So at that time, we reached out to key players from the Java ecosystem, namely Red Hat and IBM, because it's a huge effort. So we wanted to make sure that they were on board with us. And obviously, they were very keen to work towards those changes. So we think that the only way we can have a vendor-neutral playing field is basically by asking an open source foundation to lead that effort. Since then, we have selected that open source foundation, that's the Eclipse Foundation, and that whole effort is called Jakarta EE. Now, I will come back on namings because there are multiple names, and I just want to clarify what the different names are used for. So basically, Jakarta EE is this whole community initiatives where we want to change how the platform is evolving going forward. We want to make sure that the platform is able to evolve at a more rapid pace. We want to make sure that anybody that is willing to contribute can easily contribute to the evolution of the platform. We want to make sure that it's not a single vendor play. So that's why basically all the IP now is owned by the Eclipse Foundation. So we started with IBM and Red Hat, and since then a bunch of actors have joined us, like Tommy Tribe, the folks from Pyara, Fujitsu, Lightband, and so on. So it's really not just an Oracle-driven effort. It's really now a community effort. Now, let's talk quickly about naming. If you have been following the news, you might have heard about EE4J. So last summer, when we started to go public around our intentions to basically open source the development of the platform, at that time, we needed a name to call that. We use EE4J as the initiative, as the project name. And I mean, it was clear that some people didn't like that name. So we had to come up with the new names. So what we did, I mean, what the Eclipse Foundation did is basically the foundation asked the community to propose different names. So we had a long list. That list was filtered out for legal reasons. There were some names that we couldn't use. Also for other reasons, like some names didn't really work in some regions. So at the end of the day, we had a short list of, I think, 7 names. And then again, the foundation has asked the community to basically vote for the name. And the name that was picked was Jakarta EE. So Jakarta EE is basically the name of that whole initiative. There's Java EE. So Java EE is an Oracle own brand. Java EE doesn't disappear. So we have Java EE6, we have Java EE7, we have Java EE8. I mentioned that WebLogic will shortly support Java EE8. Others application server will support Java EE8. So that means that you will be able to continue to use Java EE, 6, 7, and EE8 for the years to come. I think that on the Oracle side, we have announced that we are going to support WebLogic Java EE8 at least 2025, something like that. So Java EE doesn't disappear. But clearly, the evolution of Java EE will happen under Jakarta EE. So moving forward, all the evolution of all the new release will be branded Jakarta EE and not Java EE anymore. So Jakarta EE it's the brand, and it's owned by the Eclipse Foundation. And then you might have noticed, if you have been following closely the discussion that happened around Jakarta EE, that at some point in time we also used EE.next. I mean, that was a temporary name, and that name just got discarded. So if you are confused, just think that Java EE is the Oracle brand. It will stay for many years, but all the evolution will happen under Jakarta EE, and it's an Eclipse-owned brand. And if you don't really understand the difference between Jakarta EE and EE4J, EE4J is the technical project name. So there is a EE4J GitHub organization that is hosting all the codes. But if you don't know which name to use, just use Jakarta EE and you'll be on the safe side. So, Jakarta EE, the goal of Jakarta EE is basically to evolve the platform, evolve the Java EE platform to make sure that we can address the complaint that we had through the years, like it was slow to evolve, but also address new requirements coming from the market, such as, for example, being more reactive, probably also address microservices. Also, being more cloud native, so you would want to deploy Jakarta EE application on top of a cloud provider. There are a lot of things that might be done at the platform level, those kind of things. So Jakarta EE, this is really the goal of Jakarta EE, basically evolve the platform to make sure that it can stay relevant for the next 10 to 15 years to come. Now, it's not something that is happening overnight. So we have a few interim goals. So one of the short-term goals that we have is that we want to ship as soon as possible a Java EE8 compatible implementation out of the Eclipse GitHub repos. We want to do that for multiple reasons. So first, we want to make sure that all the code that is on the Eclipse side can be used to build a fully compatible Java EE8 application. One thing that I need to mention, Jakarta EE is starting from Java EE8. So everything will be based on on Java EE8. I will spend the rest of the presentation to show you some of the new technical capabilities that we have added in Java EE8, because that's basically where we're starting for Java EE. So we want to make sure that all the code that is on the Eclipse side can be used to build a fully compatible implementation of Java EE8. That implementation will have to pass the Java EE8 CTS, TCK. So that's something that we also said, is that one of the value of the Java EE platform is the compatibility. It's something that Java EE has for years. So we want to make sure that by moving the development of the platform from an Oracle-led, GCP-led development to the Eclipse Foundation, we preserve that notion of compatibility. So that means that Oracle is donating all the IP of the TCK and the CTS of Java EE to the Eclipse Foundation. So at some point in time, you will also see in the GitHub repo some CTS and TCK-related code. So next, once that build has passed the Java EE8 TCK, there will be another build that will have to pass the Java EE, well, the Eclipse TCK. So again, we want to make sure that basically the transition of the TCK that are now closed source to the Eclipse Foundation works. And we also want to do that to start to foster an ecosystem around the code base that we have. A good example is, for example, the folks at Lightband. So they look at Java EE8 and they looked at the different API that we have in the platform, and they have started some investigation where it would make sense to add some reactive support in some of those API, like the Servlet API, the GMS API, and so on. So that's a good example, and that's something that we want to trigger, that we want to foster. We want people to start to think about what can we and where can we evolve the technology that we have today in the platform. So midterms, some of the goals midterms. So yes, something I forgot to mention. It's a short-term goal, and I think that we should reach that milestone. Well, don't officially quote me on that, but this summer we'll have an Eclipse Glassfish build that will pass the Java EE8 TCK. So midterms, and the work is already obviously ongoing to meet those midterms goals. We need to define how we will be able to evolve the different API and technologies that we have in the platform. And I think there will be a public proposal that will be proposed, I think, this week. So basically, we are not using the GCP anymore to evolve those technologies. So the Eclipse Foundation has had to come up with new rules, new process to evolve the specification. And so there are a lot of discussion going on between the Eclipse Foundation, Oracle, IBM, Red Hat, Tommy Tribe, and so on, to exactly set those new processes. It's not something easy, because I mean, there are a lot of technical issues, but also a lot of IP questions. And that's a good thing that the Eclipse Foundation is basically leading those kind of discussion. The Eclipse Foundation will also have to come up with a new branding process. Given that there will be a Jakarta EE TCK that one will be able to use to basically prove that a given implementation is compatible with the specification, they will also have to define some processes, some rules. When can you claim that you are compatible? What should it take to pass the Jakarta EE TCK, and so on and so on. So all that work is ongoing, and it's something that should be probably done, I don't know, September, October. We should have a first set of those processes in place so that we can effectively work on achieving the end goal of Jakarta EE, which is really evolving the platform. So where are we today? As I told you, it's not something that can happen overnight. So since last summer, we have a PMC, so it's a project management committee, so it's an Eclipse things. It's basically a technical committee that is driving the day-to-day technical questions regarding all of that transition. So that committee is led by Ivar, who happens to be a speaker here, and we have representatives from different companies. We have a charter that has been approved. So the charter is basically setting the direction for the whole project. On the branding side, we have the names that has been decided by the community. We have the logo that has also been proposed and voted by the community. So on the branding side, we are good. But at the end of the day, given that it's an open source project, what matters the most is the code itself. So where are we on that front? So there's this public page that is tracking live, basically the transition of the code from Oracle Java EE GitHub organization to the Eclipse EE4J GitHub organization. It's not something easy because there are a lot of projects. So there's Java EE, there's all the reference implementation that Oracle own, like Glassfish, Jersey, Mojara, and so on. But there is more than just Java EE. So for example, if you look at Glassfish, Glassfish has clustering support. Clustering is not part of any Java EE specification. So basically, we're donating more than just the Java EE platform and the reference implementation. So it's a lot of projects, a lot of repos that have to be migrated. And the process is relatively complex. So first, on the Oracle side, we need to do a legal assessment, make sure that everything is clean, that we own all the IP, that we can effectively transfer that IP to the Eclipse Foundation. So that's a lengthy process. And then once this is clear on the Oracle side, basically Eclipse is doing the same exercise, but on their side. So they are checking all the IP that we are proposing to donate, and they want to make sure that everything is clean for them on their side. So what you should really track here is this mark here, the 80%, because that basically means that the code is on the Eclipse side. So we are not there yet, but we are making good progress. And at the end of the day, what we want to see is Glassfish reaching at least 80%. That would basically mean that all the code that Oracle is proposing to donate has been transferred effectively on the Eclipse side. So that's basically where we are today. So that's a very short overview of Jakarta EE. Now, what I'm going to do next is I want to give you an overview of what we have done in Java EE 8, because Jakarta EE is starting from Java EE 8. So the initial release of Jakarta EE will basically be Jakarta EE 8. Sorry, the initial release of Jakarta EE will basically be Java EE 8. So Java EE 8 is basically about modernization of the platform and simplification of the platform. So the first API that I want to discuss is Jax-Rs. So in Jax-Rs 2, so Java EE 7, we have added a client-side API to easily consume REST endpoint. So you have this notion of a client-side Jax-Rs container that you can use to issue REST requests to remote endpoint. So you first need to have an instance of a client-side Jax-Rs container. From there, you build a web target. From the web target, you construct the actual request that you want to send. And finally, you will invoke the request to hopefully get at some point in time a response from the remote endpoint. So that's basically how it works. The thing here is that, sorry, that's very confusing. So you have this get method. That's basically where you invoke the request. But this is a blocking call. So that means that this method will only return once you have received the result from the remote endpoint. Given that you are going through the network, it might take some time. That's typically something that you don't really want to do in any kind of application. The good news is that we also have in Jax-Rs 2 asynchronous support. It works like this. So you have this async invoker. It's basically a way to tell to the Jax-Rs client-side container that you want this request to be invoked in an async fashion, so in a non-blocking fashion. And if you look at the return type, here we have a feature of a response type. In this case, this is a string, so we have a feature of string. So this request invocation doesn't block. But if you have been using the future API of Java EC, you know that as soon as you do a get on the future object, you will be blocking again. So you haven't really solved anything with that async invoker. The good news is that in Jax-Rs 2, we foresee that issue, and we have an invocation callback facilities. So it works exactly the same way. So you are using the async invoker. And when you do the request, you have to pass an invocation callback. Invocation callback with two callbacks. So the first one is the completed callback that will be invoked once we have the result back from the remote endpoint. And the second one is the one that will be invoked if something goes wrong. So in this case, you are not blocking. The problem that we have with this API is that if you have complex request chaining invocations, like you invoke a services, based on the response from that services, you want to invoke another services, and based on the response from that second services, you want to invoke the third services. If you have to write that using that API, well, good luck. You will basically, you will have a callback hell. So the code will be difficult to write, debug, and maintain. And that is what Jax-Rs 2.1 is solving. So we first have the default invoker, which is blocking. We then have the async invoker of Jax-Rs 2, which is async, but has some limitation. And in Jax-Rs 2.1, we are adding a third invoker. It's this Rx invoker, which is an asynchronous non-blocking reactive invoker. And if you look at the return type that we have when we use the Rx invokers, it's a completion stage of the response type. So it's not a feature anymore, it's a completion stage. And if you have been using the Java EC8 completion stage API, well, it's this API that basically allows you to have asynchronous tasks, and you have all the construct to chain those asynchronous tasks. So you perform an asynchronous task, and when a task is done, it will automatically trigger the execution of a different asynchronous task. This is an example using Jax-Rs 2.1. So we have a first request that goes to an external services. It uses the Rx invokers. We have a completion stage object back. In this case, it's a completion stage of JSON object. And then we have a second request. This request is wrapped in a function. So basically, the function gets a JSON object, and it will do a remote request invocation to a different services. And then it's just a matter of combining those requests together using the completion stage API of Java EC. So I have the first request, then compose basically mean, okay, you do this, so you do the first request. Once you have the result, you pass the result to my function. My function gets a JSON object, and it will give that JSON object to my second request, which will in turn use that JSON object to basically get some other information from that second services. And then it's just a matter of using what we have, what we receive from the second services request invocation. So we do a first request in a non-blocking fashion. We have the result that we pass to do the second request invocation, and finally we have the result from the second request invocation. And in this case, I'm just consuming that request using a simple invoker. So that's basically how it works in Jax-Rs 2.1. So in Jax-Rs 2.1, we have this new Rx invoker that is using the completion stage API of Java EC8. And clearly, if you have this notion of multiple requests that needs to be chained together, you'd better use the Rx invoker instead of the pure Jax-Rs 2 async invokers. Now, we also acknowledge that there are on the market other reactive API than just the completion stage API of Java EC8. So the Jax-Rs 2.1 specification has been designed in a way to let other API be used. It's up to the Jax-Rs implementer to decide if they want to add support for something else. In the case of Jersey, which is the Jax-Rs reference implementation, and now we should call it Eclipse Jersey, we obviously support the completion stage API. That's mandatory per the spec. But we also support RxJava, RxJava 2, and Guava listenable features. So that basically gives you more choice. Then something else that we did in Jax-Rs 2.1, so Java EE8, Jakarta EE initial release, is had support for server-side event. So server-side event is this very simple HTTP-based protocol that is used to basically push payload from the server to the client side. So the client establishes the connection, and once the connection is established, the server has a one-way channel to push payload to that connected client. It's widely used on the internet. It's relatively firewall-friendly, so we thought that it would make sense to standardize that in the platform, on the server side and on the client side, obviously, given that we now have two API. So we have this new super interface, SSE event, which represents an SSE event. It's extended on the two sides of the connection. So outbound SSE event is the server-side view of an SSE event. And then we have inbound SSE event, which is the client-side view of an SSE event. SSE is a one-way protocol. So you will always create event on the server side, and you on the client side you will just consume incoming event. You will never create event on the client side. So how does that work? So we have this new SSE event thing type, which basically represents a connection. So it's really a connection, and in this case, this is the server-side view of the connection. So how it works? Well, we try to reuse as much as we can from the standard Jax-Rs API. So this is the Jax-Rs resource method. We are just using the add context annotation, which was already there, to inject two objects, the connection object and the SSE object, which is some kind of utility object that simplify our life. Then we are just reusing the standard Jax-Rs annotation. And the only thing that is specific here is obviously the media type, which is the specific SSE media type. Once we have that, it's just a matter of taking the connection object and invoking the send method on that object to send the payload that we want to send to the client that is connected on that connection. We'll do that multiple times, and obviously once we are done, we need to make sure that we close the connection on the server side. So this is basically how it works. It's fairly simple. On the client side, again, we try to reuse as much as we can from the Jax-Rs 2 API. So obviously we are reusing the Jax-Rs client-side container. From the client container, we set the web target. Then we create the connection. So SSE event source is the client-side view of a connection. We have the ability to configure the connection. In this example, I want the connection to be automatically reestablished every 5 seconds if the connection is dropped. And we invoke the build method to actually build the connection object. So we are not establishing the connection at this point. We are just building the connection object. What we then need to make sure is to register a few callbacks. So the one that you need to have definitively is the one that will consume inbound SSE event type. That is basically the callback that will consume incoming SSE event. You can also, for example, register a consumer for a throwable type. That guy will be invoked if something goes wrong. And then what you need to finally do, you need to open the connection. So that's basically where you tell to your Jax-Rs client-side container to establish the connection, register all the callbacks, and so on and so on. And obviously, once the connection is established, at any time some SSE payload is pushed on that given connection, your callback will be automatically invoked. And once you are done, you need to make sure that you close the connection. In this case, I'm not closing the connection because I'm using the try with resources, so it's automatically closed for me. So the new Rx invoker, SSE, are clearly the two biggest features that we have added in Jax-Rs 2.1, but there are other stuff that I don't really have the time to cover today. So what I propose to cover next is what we did on the JSON front. So we have updated the JSONP, so the JSON processing API from 1.0 to 1.1, and we have added a brand new API to do bindings. So JSONP 1.1 is mostly about adding support for new standard from the JSON space. One of the standards that we have added is Json Pointer. As the name implies, a pointer is basically used to specify a location within a JSON document. So it's this very simple syntax like we have, like we have here. So we have here /event/location. So /event means we want to have the key value whose key is event, and in that object we want to have the key value whose key is location. So if we look at how it works, so we have this JSON document for which we have the JSON representation on the right side of the slide. So if we want to use the Json Pointer API, we first need to create a pointer. So JSON, and then we use the create pointer method, and then we use that very simple syntax. /1 means we want to work with object at index 1, so the second object, and in that object we want to have the key value whose key is the new. So once we have the pointer, we have a few operations that we can use, like get value. In this case, it would return Hilton. We have the replace operation. Given that it's a replace, we obviously need to specify what the new value should be. Something that is important is that the JSONP API is an immutable API. So if we are going to do a replace, what we get in return is a new object. We're not changing the original object. And then we have a few other operations like add, removes, and contains value that we can use to test if a given key is present. Another point, another standard that is part of JSON P11 and that is based on JSON Pointer is JSON Patch. Again, very obvious names. A patch is basically used to modify a JSON document. It also happened that a JSON patch is in itself a JSON document. So it's basically a JSON document that contains one or more operations that will be applied to another JSON document to modify that JSON document. So this is an example. So on the left side, we have a JSON patch with 2 operations. The patch is atomic, so meaning that if one of the operations fails, the complete patch will be cancelled. And we want to apply that patch to the JSON document that is on the right side. So we perform the first operation, it's a replace. We are using the JSON pointer syntax, so that means that we want to replace Hilton by Moscone West. It works, so we can move on to the next operation, which is a add operation, and that would be the end result. So this is how it works. Now, if we look at the Java side of the JSON patch API, so we need to have 2 JSON documents. The target, so that's basically the document that we want to modify, and the JSON patch that contains 1 or more operation. So once we have that, we create the patch from that JSON document, and then it's just a matter of applying the patch to the target that we want to modify. Again, this is an immutable operation, so the new, we get a new object basically that will contain the modified JSON document. In JSON P11, we also have this builder pattern that we can use to basically easily construct patch without having to go through the manual creation of a JSON patch document. So create patch builder, then just a matter of basically specifying which operation we want our patch to have. So it's a copy, then we want to have a replace, and then a add. And at the end, we just need to invoke the build to actually construct the patch. And again, once we have the patch, we just need to apply that patch to the target that we want to change. So it's a very convenient API. JSON P11 also had support for JSON merge patch. It's like JSON patch, but in JSON patch, you are applying operation to modify a document. In JSON merge patch, you are basically using key value pair to define what the differences are, how you want to modify the target document. We also have support, for example, in JSON P11 for streams. So you can do collection, so terminal operations, and you will get in returns specific JSON P type, and so on and so on. So that was the new stuff that we have in JSON P11. And what we did in Java 8, we have also added a brand new JSON binding API. So this API is to JSON what Jax-Rs is to XML. It's an API that you can use to basically marshal and unmarshal Java object to and from JSON document. So the API is basically defining the standard behavior. So if you don't specify anything, you will obtain a very obvious and common behavior that is defined in the specification itself. And you as a developer have the ability to override and customize that marshalling and unmarshalling behavior. So this is an example. We have a very simple POJO. It's a list of a conference. And we want to get to that JSON document. So everything is done on that using that JSONB object. So JSON builder create will get us that JSONB instance. Here I'm not specifying anything, so that basically means that I'm using the default behavior. And then I can use that JSONB object with the toJSON method. So toJSON, I pass it my Java object, and what I would get in return would be, in this case, a string who would contain the JSON payload that is on the right side. And obviously, it works in both directions. So we had Java to JSON, and if we want to do JSON to Java, it's basically the same, except that we're not using the toJSON, but the from JSON method instead. We pass it our JSON payload, and also the type that we want to expect. And what we will get in return would be this event object that will basically contain all the information that are included in the JSON document. So this is in a nutshell how it works out of the box. And you, developer, have the ability to override that default behaviors. So for example, if you look at the right side, so our string is called event name. So if we don't specify anything, and if we would convert that to a JSON payload, the key value would be event name. But given that I'm using this JSONB property, it would be conference instead of event name. So we have this annotation that you can use at different levels to customize the behavior, but there are a lot of things that you can override, like naming strategy. So I think that out of the box, we have 6 different naming strategy, and if that's not enough, you have the ability to provide your own custom naming strategy. You can also specify in which order the property should be laid out when doing marshalling and unmarshalling. What should we do if we have binary data? Should they be base64 encoded or base64 URL encoded or just plain byte? Maybe there are properties that you want to ignore while doing the marshalling and unmarshalling. What should we do if you have null? By default, they will be ignored, but maybe there are some scenario where it would make sense to carry while doing the marshalling and unmarshalling that null object. Maybe it has some business value, I don't know. And so on and so on. Date conversion. On the Java side of the world, well, we have a lot of way to represent date and time. On the JSON side, we basically have strings to represent dates and time. So again, this is the default behavior is specified, but you have the ability to override that default behavior. And how would you do that? Well, you would use that new JSONB config object. So basically, you are using that JSONB config object to customize the behavior of the JSONB object. So then when you are creating the JSONB object, so JSON builder create, you pass that config object to basically obtain that customized JSON binding marshaller and marshaller. Something that I didn't mention is that we also have the notion of adapters that you can use to basically go deep into the marshalling and unmarshalling mechanism. So it's a quite powerful API. But something that is quite important to mention is that on the market there are already a lot of JSON B frameworks. So we don't want to reinvent the wheel. The JSONB API is a standard API that can sit on top of existing solution. And you as a developer will have the ability to switch to different JSONB frameworks. How would you do that? Well, when you are getting your JSONB object instance, you just need to specify which JSONB framework you want to use. And you will, under the hood, it will be automatically picked up. If you don't specify anything, you will use the default reference implementation, which is Eclipse Json. So moving on, in Java EE4J, Jakarta EE, on the web front, we have updated mainly 2 API, the Servlet API and the Gsf Api. And the Servlet API is a big deal. So Servlet 4, there are a lot of small and bigger features. But Servlet 4, there's something which is really important for the server-side Java world, and that is basically adding support for HTTP2. So in Servlet 4, we have added server-side HTTP2 support to the platform. I don't have the time to go over HTTP2, but in a nutshell, HTTP2 is about reducing the latency of a web application by switching to a binary-based protocol. HTTP 1.1 is a text-based protocol. HTTP2 is binary-based. In HTTP 1.1, if you need to fetch multiple resources to render an HTML page, for example, the client will have to do multiple requests, and under the hood, it will have to open multiple TCP sockets, which is very expensive in terms of resources on the client side and on the server side. In HTTP2, to fetch the same hundreds of resources, the client will have to open a TCP socket, and then it will have the ability to open multiple virtual connections, which are called streams. And why? Because all those streams are basically will be multiplexed using that binary-based protocol. And there's something which is very key for you developers about HTTP2 is the fact that HTTP2 doesn't change the HTTP semantics that we have been using for years. So we still have this notion of request response. We still have this notion of HTTP headers, HTTP cookies, HTTP verbs, and so on and so on. So for you developers, nothing changed. You take your existing servlet application, you deploy it on top of a servlet 4 container. It will be out of the box HTTP2 capable. Nothing's changed unless you want to use one of the new HTTP2 features, which is called a server push. So server push basically gives the ability to a server to proactively push resources to a connected client. So with HTTP 1.1, the client do a request, the server will send a response. With HTTP 2, the client do a request, the server can decide to answer with one response or more response. So this is typically used to proactively push resources to the client cache. So the client asks for an HTML page. The server will obviously answer with that HTML page, but it will also try, for example, to push the CSS proactively, CSS that is needed to render that page. And again, this goes with the idea that we want to reduce the overall latency of the web application. So if you want to do that, you will have to change your code. So this is always tied to an incoming request. So there should be an incoming request, and then the HTTP2 container can decide to answer with more than just one response. So we have the incoming request. Then from that request, we need to have the push builder object. So my request new push builder will get us that object. And then we need to construct the request that will try to push the resources to the client. So we have the ability to set the headers that will be used to push, that will be attached to the HTTP response that will push the resources. We obviously have to define the path of the resources that we would like to push. And then we invoke the push method. So this is basically where we tell to our server for container, okay, I would like you to try to push these resources. There is no way to know if the resources will be effectively pushed. It might happen that the resources are already on the client side, or that the client just decline any push resources. So you shouldn't assume that because you have pushed the resources, it will be on the other side of the connection automatically. But anyway, overall, this should reduce the latency of web apps. So HTTP2 support is really the big deal for the Servlet API. Then we have also updated the Gsf API, and one of the nice things about Gsf 2.3 is that it supports HTTP2 server push out of the box. So you take an existing Gsf 2.2 application, you deploy it on top of a Servlet 4 container that supports Gsf 2.3, and automatically it will be HTTP2 capable, and not only that, all the resources will also be automatically pushed using server push. Why? Because the Gsf frameworks know what resources are needed on the client side to render a page. So it will automatically try to push those resources. So that's one of the nice features that is part of Gsf 2.3. And then there's a bunch of other features which are very useful if you are a GSF developers. Like we have this new WebSocket component that you can use to use WebSocket with just the Gsf API, and so on and so on. So a lot of nice goodies in Gsf 2.3 for GSF users. So moving on, two API which have been updated in Java EE8, Jakarta EE are CDI and bin validation 2 from our friends at Red Hat. So CDI 2 is basically about boosting the adoption of CDI outside of Java EE. So CDI in itself is a relatively large specification, so that was an issue if you just want to use a pure Java EE runtime. So basically what they did, they split the specification to a more modular approach. So there's a core based on that, there's CDI for Java EE, and then there's CDI for Java EE based on that. Obviously, we are consuming the whole thing. They also define how you can bootstrap a container using just Java EE. It's not something that is useful for us Java developers because the CDI container is managed by the application server. But over time, this is something that might be useful. If Jakarta evolves toward a more lighter, more modular approach, that might be very useful over time. And nevertheless, there are things that are quite useful in CDI 2 for us Java developers. So we have this event mechanism since the beginning of CDI. So basically, we fire an event, and then we can have an observer somewhere else in our application that will be invoked whenever we fire the event. We can have more than one observer, but the problem is that when we have more than one observer, until CDI 2, we had no clue in which order they would be invoked. Now this is solved in CDI 2 with the use of the @priority annotation. We have the ability to set the observer ordering. It's something that is quite nice. And something that is even more nicer is this. So it's basically the same event mechanism that we had, but if you look at the previous one, everything was happening in the same thread. Now we have a fully asynchronous model. So basically, I'm firing an event using this fire async method. So that means that I just want to shoot an event. So my code will return directly, and then I can have one or more async observer. And an async observer is just a method that is using this new @observer async annotation. And obviously, that async observer will be invoked in a different thread. So this is a fully asynchronous model, something which is very nice. And finally, bin validation too. So bin validation was basically about adding support for constraint validation that were part of Hibernate validator, like not empty, not blank email, and so on. So standardize them. And also adding support for the new Java EC8 construct, like supporting the optional type, having the ability to do constraint validation using the new date and time API, and so on. And finally, to conclude, we have also added a new security API. And the name of that API is misleading, because it's not because we have a security API that the platform was not secure before. The goal of that API is to fill some gaps and also simplify how you can apply security concern. For example, by adding this notion of identity store. An identity store is basically where you will store your users. We have an LDAP1 and a database 1 that are defined right now. So this is how you would work the database 1. So we have one annotation that you can use to basically tell to the app and to the app container where your users are stored. We are also adding a new authentication mechanism for web application. Again, it's not something new. We had JASPIC, but JASPIC is very difficult to use. So this is more simple. Out of the box, we support basic auth, form auth, and custom form auth. And you have the ability to define your own using this new HTTP authentication mechanism interface. So I have an example that basically shows how it works. So we want to secure this servlet, and we only want to allow user in roles foo to allow to get in. So first, we inject our custom HTTP authentication mechanism. Given that it's a custom one, we need to make sure we implement the validate request. And not only that, we're also injecting an identity store. And the authentication mechanism will automatically pick the identity store to do the user validation. So it's a relatively simple API to use. So wrap up. So today we have Java 8. We have quickly discussed some of the goodies that we have in Java 8. Java 8 will remain for the years to come. But the evolution of the platform will happen within Jakarta EE. So I really encourage you to check what's going on in Jakarta EE. There are a lot of things happening right now, and now it's really the time to get involved. If you don't have the time to follow everything, I would encourage you to just join the community mailing list. And there are already a lot of discussions that are happening there. So I mean, it's really an exciting time. We have basically put everything in place to reboot and make sure that the enterprise Java platform remains remain relevant for the decades to come. So with that, I hope it makes sense. And before I forgot, so the Belgian fries and the French sprout. Thank you.